Hey guys, welcome back to another episode of Simuleos, the only channel on Twitch that does the Arcane algorithm archive stuff, I guess? I don't know. Anyway, today we're going to work on the same thing we worked on yesterday. I wrote something down. I think it's going to work for visualizing a tree. Should be straightforward. Let's just go. You know, like, I feel like we spent way too long on it, but that's okay. That's okay. Sometimes things take longer than you expect. That's how it goes. Anyway, guys, Dem Applause, Dirtface Dave, thanks for coming in. Let's go ahead and CD into projects, scientific visualization library, CD projects, SciVL, and let's go from there. Okay. So, what we're going to do then is we're going to go into source, and where did I put it? I think it's going to be in aux functions. Pop down here to the bottom, and let's see what we got. So if you guys recall, let me just run the command real quick. The issue is we're trying to draw a tree. let me run it, and you'll see obviously what's wrong. What did we call it? It called it traverse. We have what could be described as the first row and the second row of a tree drawn, but all the subsequent rows are not working. So let me show you what we're trying to do here with Zernal, and then we can get started here. Okay. Again, I'm going to have to open this up twice because of the weird bug where I'm not able to draw on it with my tablet for the first time. I'm not really sure why, but it happens, and we're good to go. So, trees. Trees obviously can have an arbitrary number of children. They could have 2, they could have 4, they could have, 1. Doesn't really matter. What we want is kind of a general tree drawing scheme. So, one way to do this is... basically to take your central root node, which is the top of the tree, and move it left and right with some sort of offset, right? Now, the thing that I failed to consider last time, and the thing that's kind of nice in our case, is that we're dealing with balanced trees. So because our tree is necessarily balanced, it means that, well, if we move this further, and we say that this has 3 children, and this has 3 children, 3, then we can kind of split it into 2 different boxes, kind of like what Buttercake was saying yesterday. And these 2 different boxes will be boxes of 3, so 1, 2, 3, 1, 2, 3, so on and so forth. So then when we put the nodes down here, well, they're already kind of split into these boxes here. And if they have children, we just split their individual boxes into further boxes, if that makes sense. So now, all we need to know is the available space that each child has. And then we can appropriately place them. And I think I wrote something down that will allow us to do this. Then all we have to do is figure out the Y positions, and then we should be good to go. So that's the goal, and we'll see how it goes. Pop this over here, pop this over there. Of course, if you have any questions, comments, concerns, anything like that, feel free to let me know in the chat box, and I'll do my best to respond to it as soon as possible. Okay, so over here we have a list of all of the X, Y, and Z positions. The Z positions, as expected, are all 0, 0, 0, 0, 0, 0. The Y position should vary from 0.9, 0, and negative 0.9. Unfortunately, the Y positions are going to negative 1.8, which means there's also something wrong with the Y positions. So what I want to do, where's our create tree? Here's our create tree command. What I want to do is I want to first see if we can figure out what's wrong with the Y positions, because I think those will be a little bit easier than the X positions. And then we figure out what's wrong with the X positions, right? So, in principle, we should never have the Y positions drop below negative 1, right? So our box size is from negative 1 to positive 1 in both X and Y. So we don't want our positions to go anywhere past that. So let's go ahead and figure out why this is happening and go from there. So first of all, the way I have this set is 2, which is the size of the box, minus 2 times radius. So this is just going to be the total size of the box that we're allowed. And that's because we don't want the objects to go off the edge of the screen, so we subtract 2 times radius. We multiply this by the number of row, so the row that we're currently on, divided by max row. And I subtracted 1 from each of these guys. So if our number of row is 0, for example, which would be in the case of the final row, we should be seeing... Oh, I see. Okay, I definitely see the problem now. Okay. Good. So, here's the issue. This formula right here, let's just go ahead and put it in Zernal. We say it's some offset. Oh, where's my pen? There's my pen. We say it's some offset. Page, new page before. So we'll say Y component. Okay, so we say we have some ball, and they should be located equidistant from the other balls, you know, something like this. We say that it's equal to the XY range, which is this guy over here. GTK is beautiful. Yeah, I like GTK, actually. I don't mind it. KNX, thanks for coming in. So Y range times. And what I wanted to do was equally distribute this. So I was thinking, what we do is we give, how do we do this? We say Y range divided by the number of rows. Let's say rows. There we are. So Y range divided by the number of rows. This will give you, you know, an equally spaced tree, I guess you could say. So this gives you the size of each box. So if, for example, Y range is 2, that's okay. So we do this. Then we basically say the position is going to be equal to Y range divided by number of rows. And we're going to have to multiply this by I. And I, in this case, is going to be equal to max rows minus num row. Something like this. So the idea is that we have some sort of dx, if you will, or dy, and we're kind of shifting it. So dy1, dy2, dy3, so on and so forth. And I think if we do something like this, we should have the positions relatively straightforwardly defined. So let's see if we change our guy to that. So again, we have this defined. So we should be able to divide this by max row, right? And this will give us our dx. And then we should be able to multiply this by our I value, our iterative value, which is going to be max row, subtracting num row, which is the row that we're on right now. So in this way, we're going to go through all the different rows. Let's see what happens if we make this, and we'll see where the Y positions are at. Traverse. Okay, they're upside down, and they look almost identical to what they were before. Now here's the thing. What we need to do now is we need to subtract 1 at the end here. So let's go to SciVL Traverse. Oh, we need to make that. Okay, now we do SciVL Traverse. Okay, this ain't so bad. It's almost right. And what we need to do is we need to add the 2 times radius in here. Oh, 2 minus 2 times radius. So it should be minus 1, but it shouldn't be minus 1. It should be minus 1 plus radius, or is it minus radius? Let's just do plus radius. Plus radius. Let's go over here and make that. And we should see, where's the last one? Here? Yeah, okay. So now they're all equally spaced. They're upside down. We can fix that pretty straightforwardly, just by multiplying by -1. So what we're going to do then is take this whole term and multiply by -1. There we go. That's the most beautiful term you could possibly have written for this. I'm like 90% sure. Make that. And this should get the Y positions correct. Yep, okay. So now the Y positions are in the correct order. The problem is these pesky X positions, which is what I said earlier. It's going to be a little bit of a pain. So, like I said, we're going to have to find some sort of way to define the box in which each of the small balls are going to be put into, right? So we're kind of discretizing the space in a way. So let me get a quick sip of water, and we can work on that next. Oh man, this is either going to be really good or really bad. I'm actually kind of worried about this X position one. The Y position was just me failing yesterday, but the X position, I think, takes some thought. Okay, so what I wrote down was that basically we're going to be reading in some sort of offset. And I said the offset is going to be equal to, let's just pop down here and draw it again, page, new page before. The offset's going to be equal to some sort of, well, it depends on the box size, right? So let's say we have a giant root node here, and we have 3 children nodes, okay? What we're going to do is we're going to take the space allocated to the parent and divide it by 3. 1, 2, 3. Here are 3 boxes. Right here. And then we're going to say we need to, first of all, add, or let's say the X offset is going to be equal to, what did I say? I said it was going to be equal to the current X position. So we'll say X position of the root guy. And then what we need to do, I think you're making this harder than it has to be by trying to draw a whole tree at once. I'm not actually though. We're not drawing the whole tree at once. this is exactly what we're doing. We're drawing one node at a time. It just so happens it's visualized all at once. So like if we put a time step in between each of these guys, you'd see that it's drawing 1, 2, 3, 4. Yeah. Yeah, so, I mean, unless you have a way to make this easier, I don't see any way of doing this. Besides, we've done this before a while ago when we did Huffman encoding, and it was something like this in the end. Besides, you can't draw the whole tree, actually. Let me think about it. Yeah, there's actually a good article out that I remember coming across when we were doing the Huffman encoding stuff. Let me go over here, and let me do drawing something like this. No, visualizing binary tree. Hey, Buttercake, thanks for coming in. Actually, I'm not sure if I can. Yeah, okay, so I don't know where the article is that I looked up earlier, but I promise it's there, and it kind of describes how to do everything. It's just, I don't know, it didn't really work for us that time, so we tried to do it again. Anyway, it doesn't really matter. Point is, I'm pretty sure what we're doing right here will work. We just have to kind of get it all drawn, and we go from there. If you can think of a better way to do it, Dirtface Dave, feel free to let me know, and I will, I'll try to implement that, if it's easier to implement. Okay, so what we're going to say is we have, each of these elements is going to be, let's see. Oh man, I wrote down like 5 different things. I'm thinking of functions like draw node and draw leaf, where draw node decides which one to call for the node's children. Yeah, again, but we need the entire tree, otherwise we don't know the position of the nodes. You know what I'm saying? Because like if we're doing a binary tree, the node position is going to be different than if we're going to be drawing a like a tertiary tree, I guess, like a tree with 4 children. I don't really know what those trees are called. Okay, so what we're gonna say is, one second, the new x position. Oh, come on, I did this yesterday, and then I kind of failed to write this down. So, we say it's going to be equal to the box size. Okay, whatever. We know what the new x position is going to be. The new x position is going to be... basically, we have the dx, and it's going to be basically 0.5 times box size. Let's say this is going to be, yeah, let's say box size. Plus I times box size, where this is defined as a box size. So this right here, what I'm shading in red, that's a box size, right? So then we basically have this drawn in that way. We give it a slight offset, and we kind of go from there, where I starts counting at 0. Okay. Now the problem is we have to put this in a relative position. So we have to make this relative to the position up here, right? So this means that we have to relate this here, here, and here, right? Now, I promise I wrote this down, but like my notes are really scrambled. That's a big mistake. You should probably like better define your notes. So here are my notes. They're like kind of all messed up. I don't know if you can see it. Here, maybe I move it closer. Anyway, doesn't really matter. Let's go ahead and try to figure this out because I remember it not being too difficult. Okay, so we're going to be iterating through all of the children, right? We have the total size of the box here, which in this case for the first node is going to be 2. And we know the locations of the next objects, which are going to be, and we know the location of this object here. So this object is going to be at location, let's say 0 or something like that. So I think all we need to do is we say, location 1, so it's going to be position here, and we have the position there. So then we just have to find the distance between the two. So it should just be position 1 second. The position of object 1, so position 0, and it should just be position minus position 1, which is the position of the new object. Let me think. Is that going to do it? Oh, I see. It's probably going to be minus 0.5 times box size plus I times box size divided by numchild. Okay, where the box size here and here are slightly different. So something like this. We'll figure it out. Okay. Anyway, I have an idea of how we're going to do this. We're just going to try it. Go over here. Let's see what we have. So right here we have the offset x. Where are we? We have the offset x, and we say numchild divided by 2 minus I. I think I kind of screwed up here. So let's see if we can do this a slightly different way. We're going to say box size. Yeah, let's go down here. So we're going to define a double box size in here. Here, and then we're going to pop down here. We're going to say box size. It's going to be equal to 2 divided by power of, and it should be number of children. 1 second, children. And again, we're a balanced tree, so we can kind of get away with this. Raised to the number of rows. And I think it's num row, yeah. Yep, okay. And I need an additional guy there. Yep, okay. Good, so this should be it because the total size of the drawing area is 2. So this should be okay. And then we're just kind of parsing it into individual boxes. And this will give us our dx. Okay, so now we have some sort of offset. And what we want to do is we want to relate the first guy to the second guy. So that means we have a dx. And I guess we're just going to subtract out the dx and see what happens. So we're going to do minus 0.5 times box size. I think this is still not going to work. I don't remember what I was trying to do, but I remember last night thinking, oh yeah, this is totally going to work. And now I kind of feel like I screwed something up. Plus, oh, wait a minute. Yeah, okay, let me try something, and I'm pretty sure this is not going to work, but I have an idea of something that might work if this one doesn't work. So times plus I times box size. Something like that. Right here, let's make that. Yeah, I'm pretty sure this one's not going to work. So numchild, I think is what it's called. Oh, actually, I think it's just... No, numchild's a thing. Yeah, so let's do make. Trivial traverse. Okay, okay. See how they're slightly off? Wait. Let me just go to... Maybe if we subtract this 0.5. Oh. Maybe it was okay. Yeah, let's go here. Let's do make. Maybe I just didn't need the offset. No, I did need the offset. Yep, I totally needed the offset. That just made it worse. How about we do minus... I said 0.5, but let's do minus box size. Because maybe there's an off by 1 error or something like that in here. Yeah, okay, so it seems like there's an off by 1 error, but more than that, the positions here are incorrect. You see what I'm saying? Like, these should be further out. So it should be like this guy is in front of this guy, and that guy. These are not the appropriate positions. So why is that the case? So we say box size is equal to 2 divided by power of numchild num row. Okay? So then we say, yeah, so I think one of the, we have to like, we're off by 1 somewhere. I'm just trying to figure out where we're off by 1. So we'll say it's going to be offset x, which is going to be equal to 0 in the first case. And then we want it to be 0. And then we should be subtracting 0.66. Adding, hey, AB, what up? What's up? Man, gosh darn it. Why? I'm sorry. I'm trying to keep the colloquial speech out of my stream, but that's okay. Okay, so let's see. What do we have here? We have offset x minus box size plus I times box size. What was I trying to do here? I think what I want is, so let's say it's numchild -1. This is not going to work. Okay, well this guy's in the right position. Now these guys aren't in the right position. Okay, how about we do num row -1. Oh. Make. This is probably going to do the same thing. Yeah, okay, now these guys are in the right position, but these guys are definitely... This is the same thing we had last time, basically. Okay. So now we got to think about this. Because I was pretty sure I had some idea, but now I have no idea what I was thinking about last night. Does that ever get anyone? Where like they're up late at night and they're thinking about something and they write it down. They're like, inspiration, I got it. And then they wake up the next morning and they realize, they didn't know what they were doing, because that's exactly what's happening here, and I apologize for that. Okay, so let's go back to here. We know what the dx is. We know what the dx is, right? So if we know what the dx is, right, then we should be able to iteratively go through. Inspiration was all a dream. Okay. I know what the deal is here. Okay, how do we define box size? We define box size by 2 divided by some number, which is the number of elements. So what we need is 2 different box sizes, I think. So this is box size prior, and this is the current box size. So we have some sort of global offset. Okay, I got this. I think we figured it out. So we're gonna have box size, and box size 0, I guess. Go down here, and we're gonna yank and paste, and we're gonna do power of numchild numrow -1, and then we're gonna go down here, and we're gonna say minus 0.5 times box size 0, which is the original box size of the object above us, and let's do make, and then we're gonna do SciVL as traverse. Dang, I thought that would work, and it clearly did not. Let me check here. Okay, because when we do just minus box size here, see, make, this is not what I was expecting. What? We had something that was really close just a second ago. What happened to that one? Yeah, where did that one go? What was the difference there? We had something super close a second ago. I'm like 90% sure. Oh, that's because I defined this as... Okay, if we go back here, make... And then we go here. Okay, so this one's really close in the bottom, but not in the top. So then if we go here, we do minus 0.5 times box size 0. When we make that. And we go SciVL traverse. Oh, you know, that just made it worse. Dagnabbit, why? Why am I consistently making this worse? Okay, here was the idea. We have some sort of... where's my pen? There's my pen. Yeah, okay. So we have some sort of dx here, right? So dx, dx, dx. This is your dx. And what we want to do is, we also have some sort of box up here, right? Which is going to be your offset position. So we have some sort of large box here. And I figure we subtract 0.5 times this box to bring us to this position here. And then after subtracting that, we then add dx's. So we do dx1, dx2, dx3. That was the idea. Plus I times box size divided by numchild. Oh yeah, let's try something else then. Let's do... Okay, have an idea. Okay, looking at some more of my obscure notes, let's try another one. Let's just have a single box size. This is super confusing, guys, and I definitely apologize for that. dd here, do numrow -1, so 1 row under, and then we want to do minus this, and then box size divided by numchild. Go over here, make that. And let's see what happens if we do this. Dang it, why is it doing the same thing? Offset x. Okay, so offset x, in this case is 0, it doesn't really matter. We subtract out 0.5 times this box size right here. Right? So we subtract out 0.5 times that. And then we consistently add in all the dx's, which should be right. Dagnabbit. Okay. So it's whatever position we're at, so we'll say position, minus 0.5 times box size, right? So we subtract that out. So this puts this at -1, because the box size here is 2. And then we do plus 0.3 plus 0. Or 0.6, 0.6, 0.6. Yeah, okay. So I must be off by 1 somewhere. Let me go through and let's figure out where we are in the tree, because I think maybe I'm getting confused here. So we say it's box size divided by power of numchild, numrow minus 1. So numrow should be like 1 or something in this case. So let's just output the box size and let's see what we got. New line, go over here, make that, and let's see if we can figure this guy out. Okay, well, it says we are 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. This is because numrow is not numrow. Numrow needs to be max row minus numrow minus 1. Make that. Expected primary expression before minus 1. Let's go over here and make that. And we're going to do traverse. Nabbit! Why does it say the box size is 6? Okay, let's get rid of the minus 1. Okay, this is correct. We're missing an offset though. Well, it's almost correct. Yeah, it's almost correct. These guys need to be closer. Okay, so we have the offset here, minus 0.5 times box size, and then we have to add in plus I. Let's do times, or plus 0.5, something like this. Make that. And then we do traverse. Okay, this almost looks right. Almost. No, wait, maybe. Maybe it is right. Okay. Maybe I'm okay with this. Okay. Hey, Flood from Nowhere, what's up? I'm incredibly drunk right now. I'm really sorry. Man. I know. Anyway. 710 milliliters of beer. Good on you, man. Okay. I think this is actually correct once we draw the lines. I think that's okay. So, I'm going to go ahead and draw the lines right now so that we see them, and then we can go from there. Let's go into VI source. Distributions. Okay, wait. Guys, let me go ahead and clarify what we just did here. So, page, new page before. I apologize for all of the confusion here. What are you listening to? The vapors? Okay, so here's what we did. Where are we? Here's my pen. Let's do this. I'm gonna pop back up over here. We have some sort of guy. He's in position X. Okay? He has children because, you know, that's the meaning of life, children. So his children can fit into his house. His house is of size, box size. So that's the size that he has to live with. So that's gonna be box size. Up here, box size. Okay? So what we said is, okay, each of the children need their own room. So here's 1, here's 2, here's 3. So we subtract half a box size to get to this part here. So we're going to do position X minus 0.5 of box size. Right? Then, had told me being drunk was this great? What? I don't know. I don't actually drink that much, so I don't often get drunk. You feel so unworried? Yeah, maybe that is a good thing then. Okay, so then we say 0.5 times box size, and then we're going to add in I plus 0.5, right? So plus a small offset. And then we do times box size over the number of children. Okay, so the idea is then that we're basically doing we're going through all the little dx's like I said before, but then we're adding a small offset so they're in the center of the room. I hope that makes sense. Let me know if it doesn't. I need more milliliters next time. Are you like at home or at a bar or? Okay, so now I'm gonna pop back over here and we're gonna add some stuff into the distribution so we can draw some lines. And then I think we're good to go. In fact, this create tree, what do we have here? We should be able to change the child number and everything. So let's go ahead and change the child number and the row number, and it should still work. So let's do this to, let's change the row number to, let's say 3, and let's change the child number to, let's say 2, and this should still be general enough that it works. So let's make that and see what happens. And why are these guys so close? The Y position is not correct. Dang. Is the X position correct? Nope. Okay, fine. Well, it worked for the case that we tried, so let's just go with that, and we'll try to figure this out later. So let's do make, and we'll get this at some point. I promise. Okay. So what we're gonna do is we're gonna pop down here. Now we have to draw some lines. So we should have, where's the circles? We have all the different positions, so now we just have to connect all the positions with lines, and we should be good to go. So we have product shapes pushed back, and this is going to be all the different circles. Makes no sense, but I started computer science 4 days ago, so I guess that's to be expected. Well, Fluffy, I guess Fluffy Duck, Fluffy DK, let me know if you have any particular questions. The idea is that we're trying to position these objects in space so they accurately draw the computer science structure, which is a tree, right? Let me draw the lines. And then I think after drawing the lines, it'll kind of make sense what we did here. So the question is, how many lines do we need? We have all these positions.size. So what we probably should do is we should probably have a line that connects all these different positions. Now, what I need to do is figure out how to draw lines, because I kind of forgot what I did before. So we have line here. Where do I have a line being drawn? Create line is here. We have line, array, line color. Vector 3 line color. Array. What is array? Oh, so I just have 2 positions, right? That's okay. So what I'll do is I'll say we have some sort of array that we're reading in, and should be okay. Yep. Okay. So let's pop down here and let's do it. So I'm going to do, we already have line up there. So what I'm going to do is the following. We'll say std vector of glm vec3. And then we say array, and this will be the line array, so I'll call it L array because, you know, I'm great at naming things. We would say it only has 2 positions in it. And then we go down here, and what we want to do is we want to define a line for each of these guys. So we're going to go through all the positions, but I want all of the lines to be defined afterwards. So for int I equals 0, I less than par dot positions dot size, and then we do plus plus I. Okay, positions, part of positions. We don't really need this guy. We'll keep it. Fine. So we're going to say array of 0. Okay, now let me think here. We have all the different positions. How are they held in the part of positions.size? That's very important. It should be, let me think. So it should be that they're held in some sort of depth first search order. So it should be, oh, this is going to be a pain, isn't it? Yep, this is going to be a huge pain. Because we have to connect. Dang it. Okay, so here's the problem. We have page, new page before. What I want to do is I want to say we have an object here, 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 and here. And we want to draw a line between this object and this object, this object and this object, this object and that object. Okay? Doesn't sound hard, except for the fact that we have a vector with all the different positions in it. And this vector with all the different positions in it is basically, how do I define this? it does not have, like, this is object maybe 0 in the vector. This is object 1. Then we have objects 2 and 3, 4, 5, 6, 7, 8, 9, something like this. But I need to draw one between 1, 0, 1, 4, 1, 7. Oh, 0, 1, 0, 4, 0, 7. Okay, but that's child number. Wait. Well, let me draw out exactly what we have, so there is no ambiguity here. So we're going to erase that. So here's how the elements are aligned. 2, 3, 4. Then we do 5, 6, 7, 8, 9, 10, 11, 12. Okay, we have 13 elements total. Okay, so it's 1 plus 4 plus 4. It should be plus 4 because, let's see, 1. Okay, then the next one's going to be 2, 3, 4. So we should be connecting. Maybe it's best if we just draw the lines when we draw the circles over there. Okay, so let's pop over here. And let's see, what do we have here? Create circle for all these different positions. That's okay. Ah, this is such a pain. I didn't think this would be a pain. Okay. Yeah, okay. So maybe what we should do is... So let's go into the create tree command. Vi source aux functions, and we're gonna sorry about that. We're going to go down to the create tree function in here. Okay. So what I want to do then is I want to modify the create tree function so that we can basically just draw a tree in this function here. So I'm going to have to add in a couple of different guys because this is called recursively. So we want offset x. What number does row counting start? Max or max minus 1? What do you mean by what number does row counting start? Row counting starts, we read in, man, I need some water, sorry about that. We read in, like for example, if we want 3 rows, we'll read in a 3, and then it drops to 2 to 1 to 0. And then it stops counting at 0. So we go from 3 to 2 to 1, and then it stops. Okay. So let me think, what do I want? Yes, so what I'm going to do is I'm going to read in a couple more elements here. Make this an incredibly annoying function call, and I apologize for that. Okay, so it's going to be glm vec3. What I need then is, I guess I want the color of, yes, I guess I want line color. And then I want glm vec3, and we're going to do, I guess, circle color? What do I call it over here? I guess circle color. Let's do that. Okay. This is what we need there, because I think we already have the offset being read in for the x position. So we should be able to draw the appropriate lines because we know the new x position, the old x position, the old y position. Yeah, so we should know everything, so we should be able to draw the lines from here. So now I'm going to put the create circle command in the in this function here, and then do par.shapes pushback and everything, and it should be okay to do it this way. So in here, what we want to do is we're going to go through all the children, and I think what I want to do is create the circle up here. So let's do creating the circle. This node. And we're just going to do create circle. Here. There. Bam. And we're going to say shape circle. There. Okay. So, what do we need? CVC, what's up? We were promised tree drawing. Where's tree drawing? We're working on tree drawing. I promise we're working on it. Right now, we have... Well, let me show you what we have right now. We have something that kind of looks like a tree. Object 1, 2, 3, 4, right? So it's in the right position. We just have to draw the lines. So that's what I'm doing right now, trying to figure out how to get the lines drawn. Unfortunately, because this is a recursive data structure, I can't just iterate through points like I thought I could. So I'm going to have to be a little bit tricky here, but I think we can still get this to work. So what do we have here? We draw the circle position. So what we need to do is define where the position is. So we're not going to do part of position here. We're going to do, and we're going to do radius there. And we have a resolution, which I guess we also need to read in. And the color right here, which is going to be CI color. Okay, this is circle color. And then we have a resolution, which I guess we need to read in. I'm just going to arbitrarily set these all to 100 resolution. That way I don't have to worry about it. Okay, so we do circle here, and here we're going to have to do position, which is going to be the position of the previous guy. I thought you were going to iterate through as long as the binary tree was complete. What do you mean exactly? That is kind of what we're doing. It's just... Wait, I'm not sure I understand what you mean. So what I'm going to do is I'm going to say glm vec3 position is going to be equal to the following, which should be its x position, which is going to be offset x. Then its y position, which is going to be equal to this nasty call down there, except one row under. Do this. And let's see, max row minus num row minus 1. Yep, that's a nasty call. Pop it down here just to make it a little bit more nasty. And then I'm just going to put in a 0 here, because who cares about any of this kind of nonsense. Okay. And this should, I think, compile. Okay, so this should draw all the circles again. So I think I can remove this guy here. And we should do par.shapes pushback circle, and this should be okay. So now let's go ahead and get rid of this guy. And this should compile like that. Dang it, what's the problem? Position. VI source, and let's go to aux functions. And let's pop down here to, what do I want? Circle position here. glm vec3 position. Oh, that's because, wait, what? glm vec3. Vec3, oh. I also forgot to do one more thing. So let's go here, and then let's go into VI include, and we want to do aux functions. Go down to create tree. This is a super annoying function call, and I, again, apologize. So it's going to be glm vec3. Let's just copy this. And there. And that should be okay. Right, quit. Write this. Go over here, make. Should probably have made clean. 1 second. Position was not declared in the scope. It looks like I just declared it. Shape was not declared in the scope. Oh, okay. Source distributions. And let's go down to see how I defined it before. Shape is with capital S. Make. Too few arguments in the function call. Yep, fair enough. Pop down here, create tree. I'm gonna have to add in line color and circle color. Let's try that. Too few arguments in function call. What do you mean too few arguments in function call? Oh, this is the first function call. All the way up here. No syntax coloring, old style. This is what I use. I mean, a lot of people use different things. This is what I like. So we're gonna say create tree, but I want line color and circle color. Yep, something like that. It's too cool for noobish syntax highlighting. No, that's not at all. In fact, I agree that syntax highlighting is better. I just don't use it. So what I want to do then is define line color and circle color. So we're going to say GLM vec3 line color is going to be equal to white, so it should be, is that 0, 0, 0 or 1, 1, 1? I think it's 1, 1, 1. And then we do the same thing for circle color. And we change the color to, let's do red, green, blue. So let's do no green, just red and blue. Okay, right and quit. Make that. Just brings back memories. Yeah. What happened this time? There was another error. No matching function call for product shapes pushback. STD vector pushback? Type? What? What do you mean there's no... What? Create circle position. Was not declared in the scope. GLM vec3 position. Unexpected initializer before GLM. Okay, well let's see what we have here. That's because I forgot a semicolon. Vim does not VI. Okay, let's see. I want to do SciVL and let's see how this broke. Oh, that was not what I meant to do. Let's just run it. SciVL S, and let's do, what was it? Traverse. Okay, good. Great. Fantastic. Okay. All right. Good. It's not correct. Man, we had something that almost looked a second ago. You should always fix errors from the first because it may cause later ones. Yes, that's true. VI is very primitive. That is also true. Okay, so let's see. The Y position is obviously wrong. The X position is probably okay. 2 minus, maybe it's this thing. Let's just do this. Make that. Yep. I know what I'm doing, obviously. Haha, it worked. I don't know why, but it worked. Okay, let's go. Oh, that's because I'm defining the position here. So let's just go down here and let's just say root position. Root dot position is equal to position. Make that. There we go. Got something kind of going. So now we have to draw the lines. The reason I did it this way was so that I could find the position of the previous circle. Because the position of the previous circle is very important so that we can draw the line. X isn't correct technically, as second layer should be in between the bottom layer ones. Wait, what? Oh, yeah. Yeah, well... Wait, why would it be in between? For a binary tree, that's true, but for the tree that we're working with here, with 3 elements per, it's not necessarily true. Okay. So I'm going to go down here and let's go ahead and draw the lines, and let's see how this looks. So we have the offset X, and we have the previous offset, so we can find the X positions. No problem. So let's go ahead and define an array. Oh man, this is super confusing. So here we're creating a circle for this node. Aux variables for drawing. Yep, that's what I'm going to go with. So we're going to do glm vec3. And we're going to say, too early in the morning. Wait, what time in the morning is it for you? You aren't on my time zone, are you? If you are, congratulations for being up. Okay, so let's do glm vec3, and we'll say, what am I doing? glm vec3 array is what I'm going to call it, and it's going to be of size 2. Okay, so we're going to fill the array every step down here, and basically draw 22:47 p.m. Yeah, so you're obviously not my time zone. 8:47? Oh, so you must be... Wait, where are you? Somewhere in... So you're 3 hours ahead of me. If you were in Australia or something, you would be behind me. So you must be somewhere in Asia? Huh, I didn't know that. Well, good on you. Oh, no. If it's after, you must be in Australia or New Zealand or something. It's a 3 tree, right? Yeah, so there's 3 children per every node. I'm sorry. I don't know which one I don't know where you are, but you're somewhere. I had the time zones mixed up. Okay, I'm pretty sure you have to be... Okay, I'm gonna give up. Where are you from, CVC? Yeah, okay. So we're going to say box size is equal to this. That should be okay. We don't have to output the box size anymore. We have some sort of offset. Good. So let's go ahead and fill this guy up. So now what we need, we create the tree. And here's where we draw the line. New Zealand. Ah, I guessed New Zealand too. Okay. Good. I know a lot of people from New Zealand. New Zealand's a very good country. In fact, one of my best friends here and at OIST is from New Zealand. In fact, two of my best friends. And the dean of the graduate school is also from New Zealand. And some of the good professors. Wait. I guess it was over in that area. But to be fair, I know way more people from New Zealand than I know from Australia. Sorry. Okay, so what we're going to say is create tree here. Now I want to draw the line. And that is going to be done by going into distributions and seeing how we draw lines. VI source. We're going to do distributions.cpp. We should have like a draw line or something. Line. Here it is. Okay. Line color. Good. So we should be able to push back the line. Create line. There it is. Line, array, and line color. Easy enough. So now we have to create the array. Creating array for drawing line. Okay. Any of them from Auckland? Yeah, actually. Auckland and... Oh gosh, where's the other one? Dunedin, I think. No. I'm sorry, I don't exactly know where they're from. I've heard Auckland, I've heard Dunedin, I've heard a few other locations. I'm not really sure where else they're from. I apologize. Okay, so let's go ahead and create the array. We're going to say array of 0 is going to be... Oh, Otago. It's Otago. That's where another one is from. Definitely. He's a neuroscientist from there. So I'm not really sure what he currently does. Anyway, doesn't matter. Regardless. It's Otago. It's Otago and Auckland, I think. Anyway, good. Let's go. So we're going to say it's going to be the position X. What a nerd. Come on. Come on, what a nerd. You're watching a programming stream at 8 in the morning your time. Okay. So we're going to say X position, which is going to be equal to the previous X position. So it's going to be offset X. Oh, actually, maybe I should put this before. That's fine. Let's just do it. So it's going to be offset X. Then we're going to say after offset X, it's going to be the Y position. And the Y position should be the Y position of the previous element. So this should be where we put in the this guy here of one row under. And so this is going to be minus num row. The epitome of nerd is a mathematician. Why do you say that? My sister is a mathematician, actually. Or she's going to math graduate school. But he's a neuroscientist. That's like the epitome of nerd? No, come on. Come on. Let's see. Max row minus num row. Num row is going to be 3, 2, 1. So this is going to be opposite. So maybe I have to do plus 1. Yeah, plus 1. Okay. So this should be the array 0. And then array of 1 should be equal to offset position and 0. Okay, and then we should be able to create line, and this should be reading in basically line. Then I want to do array and line color, and then we should be able to push back line. So par.shapes .pushback line. And this, I think, should draw the lines. So let's make that and let's see what happens. Oh, okay. Invalid static cast from type glmvec3 float of type float. No matching function for create line. Yep, let me check what we have here. Line color. Nerd isn't a bad word. No, it's not necessarily. But mathematics is the universal language, and there is no point in knowing the universal language if you are completely useless at socializing. Therefore, logic dictates that mathematicians cannot be the epitome of nerd. What? wait. Mathematics is the universal language. There's no point in knowing And there's no point knowing the universal language if you're completely socializing. Okay, fine. I see what you're saying. What do you think of? Let me pause the current music. Let's see what we have. Actually, wait. I will not play the song right now. I'll open it and I'll take a look at it afterwards, because what's going to happen, inevitably, I'm going to play it, and then after playing it, I'm not going to be able to play that section of audio on Twitch, and it's going to be like copyright called on YouTube. So I'm going to watch it later. Sorry about that. I know it sounds kind of silly of me, but okay, let's figure out what the problem is. No. What do you mean there's no? Okay, let's go to create line here, and line pushback array. Array is equal to that. That seems okay by me. 0.95 positions. Offset position. Oh. That's because this should be just position. Like that. You still have an error? What's your error? Come on, man. Okay, let me see. What's the problem here? We want to go to the appropriate line, which is not easy to find. Make that. Okay, it says it's going to be 243. Yep, so create line, line, array, line color. It doesn't like this one, but why not? Because I think that's exactly what we have over here. So let's go into distributions, create line, line, array, line color. We have the shape line being defined up there. We do create circles, so we should be reading in the right stuff. I have no idea. Okay, so let's see. Line color is defined as a glmvec3, as it is defined there. The arrays it's a vector of glmvec3. Positions, where are we? Oh, I'm not doing a vector here. I did an array. So let's do std vector of glmvec3, array of size 2 should be it. Make. I wrote my math exam today for 4 hours. There we go. Our tree is appropriately drawn. No problems. Dagnabbit. Okay. I wrote my math exam day for 4 hours. See, according to CVC, that is an incredibly social experience. So, no, okay, so let me explain something. So CVC was saying earlier that math is a universal language, right? So if it's a language, you have to communicate with people, right? So obviously that's a socialization. So therefore, because mathematicians do a lot of socializing via their universal language, it's obvious that they cannot be nerds, right? So that was what CVC was saying earlier. Unless I misunderstood. Now, Borox, math exam, 4 hours. What type of math exam? I apologize. I'm sorry that it was 4 hours, but hey, Romania, hate. Yep, the tree is definitely done. Okay, so what we need to do is figure out why it's crap. Offset X, position. Oh, I know why it's crap. We have the position of the current object, but what we want is a position of the children. Right? You know what I'm saying? So let's do -1 here. And let's change this to R1. And change this just to offset. And do D3D. And paste it there. And change this to 0. And let's do make. And then we're going to do traverse. Alright, there you go. It's perfect. Ha, great. I'm so glad. So glad this is working. Wonderful. Okay. So this means the Y position needs to have no negative sign? Yep, that was it. Totally it. Ah, man. Okay, so the bottom ones are working. Great. Okay, almost there. I I was not intending to quit my day job. Art is really difficult. Inequalities, math, series, differentiation, imaginary numbers, and on and on. Don't know the English words. Totally fair. Yeah, math can be difficult. In fact, I would argue that the most difficult part of being a physicist, or really any hard scientist, is the mathematics, you know? Like, it's... I had a question the other day. It was asked on, like, Quora or something like this. I don't know if I actually answered it, because I think there were, like, 20 other answers by the time I got there. But they asked how much math is necessary for programming, and, like, it's... You need a lot of math to do programming, right? But it's simple math. It's not like research math. It's not like, you know, you don't have to do all of these integrals and derivatives and stuff like that by hand. It's... math in physics is so confusing. How so? I feel like physics math is... I mean, it's straightforward, you know? It's just like derivatives, integrals, you know, it's when compared to, like, math research, I feel like it's quite a bit easier. I remember my computer science exam was a 90 minutes race against the time, during which I produced 6 A4 pages of handwriting. Yep, that's true. Having 4 hours would make that a more relaxed experience. Yeah, but they probably just pad more. Like, it's probably more. He changed it just a second ago, CBC. He said math in physics, but yeah, I understand. Having 4 hours would make a more relaxed experience. I think so, but I think the exam would also be longer, you know? Like, one of my previous teachers, probably one of my favorite instructor I had in university, he used to give 4-hour exams, but you only had to stay for 2 hours. So you'd come in, he would write a time down on the top of your page, you would do the 2 hours, and then he'd take your paper away. So, you know, if you turned in the paper late, like it was, let's say you walk in at 9:30, and you leave at 11:39, he just wouldn't accept it. He's just saying in. He never said which should be replaced. Oh, fair enough. It's 4 hours and you don't have time, bro. Yeah, that's what I kind of figured. Okay, so let's figure out what's happening with our tree here. Okay, so these 3 guys are being drawn correctly, right? Oh, except for that guy. That guy's long. Oh, no, that guy's not long. This guy's long. So where are these guys going? That's my question. They seem to be drawing, like... I don't know, they're super far away. Okay. So why is it so far away? I have no idea. I have no idea why the first guy just doesn't want to do anything. Could be because... Could be because... Let me remove this -1. And let's make that. Traverse? Okay. Why are you so far away? Why is your Y position all the way down there? I have no idea. I'm sorry, Flood from nowhere. My bad. Okay. Here's what we're trying to do. We're iterating through all the children, right? So we have array position 0, which is a position of your current object, right? Which we just drew the circle for. Then we go through and we go to each of the children and connect them with lines. Okay? So we need the position of each of the children. We have, of course, that position in the x coordinate system. The x coordinate system will simply be the x coordinate system will simply be the offset, which we've defined up here, right? So we have the x coordinate. The y coordinate should be the next iteration of y. Oh, because of the alcohol. Yeah, I forgot about that. So we should be able to do -1 here, which gives us the next iteration of y. So it's going to be max row minus num row -1. Okay. So let's write this, go here, make that. And we're gonna do traverse. If the class is big enough. Do you even know my name? Oh, gotcha. Okay, So what we need to do is figure out why this guy is so far away. So let's just output the Y positions and see if we can figure anything out here. So we're going to do std cout array of 1 0 new tab array of, that's not how you spell array, of 0 1 1. There we go. Let's see if I can get this. And new tab array of 1 2. And I'm gonna go ahead and put this on the next line. And then add in a new line. Go over here, let's make that. Let's do SciVL traverse. Okay. Looks to me like we have 0, well, negative 1.8. Down high school. Hey, the Bandit Dave, what's up? How have you been? High school health class. And it's forever ruined the letters STD for me. Oh, yeah, fine. Fair enough. STD stands for obviously standard. Yeah, standard. Yep. Okay. Good. Now the question is, why is this a negative 1.8? And is this even what I'm looking at? Negative 1.8, negative 1.8. Yeah, okay. So there's 3 of these guys that go to negative 1.8. This guy, and this guy. Okay. So why do they go down to negative 1.8? Super good question. Under what situation would this give us negative 1.8? So let's see. It's going to be 2 minus 2 times radius. Radius is 0.1. So this means that divided by max row times max row minus 1 plus radius 0. Okay. Yeah, in health class, that's what it stands for. Sexually transmitted disease. But in physics class, it's always standard, like, error or whatever. Okay. Like, I don't know. Anyway, so 2 minus 2 times radius divided by max row times, I guess this means that num row minus 1. I guess this means that num row minus 1 is equal to 0. So it's going to be 2 minus 2 times radius times max row, or divided by max row times max row. So that would give us 1.8. Okay, so that gives us 1.8. And then after that gives us 1.8, we then subtract 1 plus radius. No, that doesn't make any sense. Let me just solve this real quick. Because obviously I'm doing something stupid. You really need the chat on a different screen so you can more easily stop yourself from getting distracted. It's fine. So let's write down this equation. It's going to be 2 minus 2 times radius, which is going to be 0.2, divided by x times x minus y minus 1. Okay. And then this whole thing is going to be, where are we? There it is. So then that whole thing is going to be minus 1 plus radius. So it's going to be this whole thing minus 1 plus 0.1. And this is going to be equal to negative 1.8. Okay, so let's see. How do we get this? First of all, we know x is going to be equal to 3. So 3, 3. Good. So let's just go ahead and solve. It's going to be 0.9. So this gets equal to, 1 second. Is it multiplied by 0.9? 1 second. No, it's just adding 0.9 at the end. Okay, so it's going to be minus 0.9. So this means this whole guy is going to be equal to 0.9. 1 second, I'm doing kind of crummy math. If I fail at algebra, I'm sorry. 0.9. Okay, so it's going to be 2 minus this. So what we can do is we can subtract 2 from here. So it's going to be equal to, let's see, it's going to be negative 0.9. If we subtract 2, it's going to be negative 2.9. And then get rid of the negative sign. So it should be here and there. Okay, so now we're going to multiply by 3. So this is going to be equal to 9 minus 0.3, so 8.7. Then we're going to divide by 0.2. So this is going to be times 5. So 8.7 times 5 is going to be 8.7 times 5, right? So this is going to be times 10 divided by 2. So it should be 4d 3.5. Okay. So hopefully this will give us an integer in the end, because it doesn't seem like it will. So it's going to be 3 minus y minus 1. So it's going to be minus 2, so equals 40. Yeah, I did something wrong. That's clearly an incorrect algebra. I apologize for that. Let's just pretend that didn't happen. Yep, that didn't happen. No, that happened. Pretend that didn't happen. What a weird way to number a complete tree. Tree should be breadth first, not depth first. Sacrilege? Yeah, that's the thing. I couldn't figure out how to make a tree that was breadth first search instead of depth first, you know? I couldn't figure out how to do that. You really need chat on different screen? Yeah. For a solar powered calculator, I have a solar powered calculator somewhere. Like, I could just grab it. Okay. 8 times 7 equals 56. Did I do something wrong here? Yeah, I probably did something wrong. Okay, let me just figure this one out real quick. So, the issue, right? The issue is that for some reason, these guys are going all the way down to negative 1.8. They're at the appropriate x position. The y position is incorrect. So what we need then is we need the position of... We have the current position, which is the position that we drew the ball. Then we need the position of the line here, which is going to be... Gosh, I can't figure this one out. That beeps whilst he can attach... Wait. For a whistle thing that beeps when you whistle that he can attach to his calculator. Wait, what? Why do I need a whistle thing? I don't even know what you mean by whistle thing that beeps when you whistle that he can attach to his calculator. I don't understand what that is. Okay. So, the positions of the last objects are correct in that they're negative 0.9. So if those guys are correct, 2 minus 2 times radius, that should be... Yeah, we're literally going into the next set. And we're saying its new position. I don't know. Someone else is drunk too. Hey, happy little rat. Also, Galloway, thanks for coming in. Okay, so what do I want to do? I want to figure this guy out. Now you're talking about calculators. I remember this. Quite fun. Y'all may like it here. One of those annoying things that would beep all the time when you didn't whistle that predated Bluetooth tags. Oh, yeah, 1 second. I'm sorry. It's the cursing, I think. So we had some guy who was like cursing way too much, and we had to, I don't know, get rid of that. My apologies. I think you're still okay. Let me check real quick. Where are we? Yeah, you're still okay. Sorry about that. And I can still read it, so it's okay. You attached it to your keys? Probably. Whistle was probably the word that got you. Okay. So we need to find the Y position here. I keep saying that, but I can't figure this one out. Because we literally set the Y position in the next time frame to be this, right? So it should be literally that. It's just number minus 1. So, but if we do that, offset X, and we run this, it's totally not correct. Yeah, I'm not exactly sure what happened there. I'm not sure which word it was that pulled it off. Okay, now let's check the Y positions here. One Y position is 1.8, right? So that's clearly wrong. This 1.8 is wrong. It's 1.8 again. So let's do, instead of minus 1, let's do plus 1. Let's go make. Oh, okay, well that's done. Great, okay. I don't know which words it is. I'll check it after stream. Okay, good. So now all we have to do is put the lines under the balls, and then we should be good to go. Great, okay. We're getting there. Okay. I'm sorry. Okay, so what do we have here? I don't know why it was +1 instead of -1, but whatever. So what we need to do then is push back the circle after we push back the line. But we have a bit of a problem. Okay. Yank. And if we just do it here, you're going to see immediately one of the problems. So let's make that. Fail traverse. Yeah, okay, so the last circles are not drawn. That's exactly what I expected to happen. So let's... 2 words is considered spamming. I don't actually know. I'm going to have to check what Nightbot settings are, and then we can go from there. Okay. For the record, on the one hand... Oh, those lines are above the circles. Dagnabbit. Okay, so what we then need to do... We created all the circles. We pushed back all the circles, but we want all the circles to be ahead of the lines, right? Because the way we have this is we have a vector of all the different shapes, and I want it to be that the circles are ahead of the... The circles are ahead of the lines, so it draws all the circles before drawing all the lines. That's what I wanted. So we draw the circle, then we draw the lines. We draw the circle, then the lines. James is very vanilla. Yes, I'm always very vanilla. Sorry. I apologize. I didn't... I'll check the filter again. I'm not really sure what it's filtering out. Okay. So let's go ahead and DD here. And create circle, paste here. Yeah, that's what I want. Okay, what we can do... What can we do? We want all the lines to be underneath the circle. So we want basically to draw all the circles, then to draw all the lines. We draw the circle first, draw the line, then we draw the next circle. I thought... Let me think. So let's go through and let's figure this guy out. So we have page, new page before. If you don't take into account the fact that your head will burn afterwards, alcohol is great. Yeah, you said that multiple times. Okay, so we're going to say we have a circle here. We draw the circle. Then we draw the line to the next circle. We draw the circle. Here. Here. But we want to draw the lines... You know what I realized? We want to draw the lines first, not second. Because if we draw the lines first, it iterates through 1, 2, 3, 4. So what's happening here is that the circles are actually being drawn first. That's the problem. The circles are drawn first, and then the lines are drawn second. Okay. Okay, okay. We can deal with this. So we want then... We create the circle. Annoying lecturers who set assignments due during mid-semester break and require them to be dropped off physically. Oh, yeah, yeah. I know what you mean. Okay. So let's get this drawn. We have to move the circles to the back of the... Oh, let's just change the position here. So we're going to grab these guys. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So D, 9, D. And we're just going to put this up here. Right before create tree. Go here. Make that. And we're going to do traverse. Okay. The Z is always 0. It's just in one plane. Not quite good enough. I need to get this guy under there. So let's see. If I draw, we have the position there. And we know the position of the new object because it's array 1. So why don't we just do create circle here. And we put it down, create line. And then we create the circle here. And we say position of 1. Oh, I'm sorry, array of 1. And then we do it this way. Let's do make. And traverse. Well. Yep, that worked. Crap. That you have drunks. I have the impression that you have drunks, is that correct? That you hate drunks? No, I don't hate drunks. I just, I don't drink very much myself. So usually when I'm in one of those situations, I'm always a designated driver or something like that. So, spooky tree skeleton, that's exactly what we have. Circle, array, radius, circle, color, 100. Oh, I forgot to push back circle. Let's go up here, and let's delete this. Go over here and make that. Yeah. Okay, that didn't help. That did nothing. Yep, we're still screwed. And we didn't even draw the first circle. So, Huh. What do we need to do? I'm so confused. We draw the line, then we draw the circle. Okay, should be okay. Right? Oh, and then we draw the next lines. Oh. I have an idea. But I don't know how this is going to work. We want all of the lines to be drawn. Then we want all the circles to be drawn. Right? So, we need the lines first in our array of parameters. I should just create a separate set of parameters that we draw first. But that would be too easy. Okay. Num children, we go through all the number of children and we push back the lines. And then we push back the circles after that. No idea. Okay. This is again me flailing. I'm not a big fan of me flailing on stream. Anyway, we're mostly there. We have the tree drawn. We have the lines drawn. We just have to put the lines under the circles. So we're getting there. And then we'll have our tree completely drawn. And then I think tomorrow we can do the visualization of the searches. And I think we should be pretty good. Learn to make and run stuff? Yeah, I could. But if the make doesn't work, then the double ampersand doesn't make sense. You know what I'm saying? Okay. Okay, what we could do is we could go ahead and allocate the space for all of the elements that we're going to be putting into the system. So this means that we have X number of... Right, so we could allocate the space of all the shapes. So every line and every circle is a shape. So we have X circles, so here we have 4 circles and 3 lines. The next set we have... Oh yeah, fair enough. You're right, CVC. Okay. So then we have 9 plus 3 plus 1, which is 13. And we have 3, 3, 3, 9 plus 3 minus 1. Yeah, okay. So the number of lines is going to be equal to the number of... let me see. The number of lines is going to be equal to the number of shapes minus 1. So we'll say number of lines. Wow, look at that. Is equal to number of shapes, or number of circles. So we can allocate the space beforehand. And we can... Yeah, okay, I have an idea. This is probably gonna be crap, but I have an idea. Okay, so we know the number of shapes that we need. So let's go into, actually, VI source, distributions, down here. G. And what I want to do then is I want to reserve the space for all these objects. So where are we? We're part of positions. Part of positions.size. Where do we create the tree? Number of elements. Node number. Oh, we have the node number. Okay. So then we want to do m equals n minus 1. Yes, that's exactly right. Okay, so we want to do par.shapes.reserve. And we want to reserve space for node num times 2 minus 1. Add that guy there. Okay, so we've reserved all the space, and what we might need to do is push it back real quick with all the different objects. But I'm going to try something over here, and we're going to say par.shapes of, and we're just going to say we should have some iterator that goes through. So how do we know what number we're on? We don't. That's part of the problem. I want something like par.shapes of I equals line. I've got another 30 minutes of streaming for the day. Well, usually. I might end early if I can't figure this guy out. Then I want to do I times 2 minus 1 or something like this equals circle. Something like that. Right, so we need some sort of iterator that goes through and constantly adds 1. Yeah, I have no idea. Okay, so let's try this out. We're gonna do, okay, the circles and lines are in the appropriate places. That's good. If we just read in an int I, we could probably go through something like this. 7.5 more hours in? Yeah, well, depending on time zones. I'm not streaming for that long. At some point, usually around 2 hours in, it's hard for me to keep going because I just don't know what to do anymore. Kind of like right now, I have no idea how to fix this problem. Okay, so we're gonna do glmvec3 color. That's okay. If we do int I, we have number as a row, we have number of children. Yeah, let's just do int I. And let's see what happens. Nope, that's not going to work because we do it recursively. Dag nabbit, freaking recursion. No, this is not going to work at all. Okay, so we've reserved the appropriate amount of space, right? We want all of the... Screw it, here's what we're going to do. We're going to push back everything. And then we have to swap elements appropriately. So we do par.shapes.pushback like we did before. Line and par.shapes.pushback. Circle like we had before. Okay, this is what we have before. We know that some lines are ahead of some circles. However, there's one way we can do this, which makes it so all of the circles come before all the lines, right? And that's by doing it up here. Okay, so we do this, and then we do create circle. What do we want? We want here. And put this up here. Okay, so we're going to make this real quick. Hopefully it works. Okay, so array of 1. That's because this should just be position. Go here, let's do position. Write this, go here, make. Okay. Idea. We're gonna do traverse. Okay. Oh man, that's not what I want either. Why is it kind of sort of okay now? I wanted all the lines ahead of all the circles, and I thought... Oh, that's because this needs to go under. So D9D. And paste. Make that. Traverse. Okay, good. So now we're in the exact opposite position of what we want. All the lines are in front of all the circles. So, what I want to do then is something really hacky. VI source distributions, and let's go down to the bottom here, and I'm going to do an std swap of all the elements going inward, and that should probably do it. So we have here, we do the create tree, then we say for come on, int I equals 0, I less than par.shapes.size divided by 2. We want to do plus I, and we're just going to swap all the elements because I've been spending too long on this. CD swap par dot shapes dot of I and par dot shapes of I times 2. Like that. Dagnabbit. What happened? I thought this would do it. Okay, so for the record, here's the problem, right? So let's go through and explain this again. Page before. We have a vector of all these elements. So we have a vector of shapes. Here, right? So here's our vector of shapes. When we're drawing the shapes, it goes element by element. So 1, 2, 3, 4, 5, right? So what we want then is we want all of the circles to be up here, and then all the lines to be down here. Oh, I'm sorry, the other way around. We want all the circles to be here, and all the lines here. So that the lines are drawn first, and then the circles are drawn afterwards on top of the lines. That's what I wanted to do. So I thought, okay, well, here we're in the situation where all the lines are drawn before all the circles. So, yeah, I thought we could just swap them and we'd be good, but nope, even that is not working. So let's take a look at what we have here. Let's run it one more time. Okay. Ugly and simple way to do this is pass vectors for circles and lines to create tree. Yeah, I could do that. And then, yeah, you're right. And then put them into shapes later. Let's see, par.shapes. Yeah. Alright, I'm going to do that because lines, circles. Let's go up here, DD. We know all this, so we're going to say yeah, okay. We'll get this in just a second. So we want to do std vector of shape, lines, colors. And then down here we'll say for int I equals 0, I less than, we want circles to be first. Oh, lines to be first. Dot size. Then we're going to do plus I. There. And then we're going to say, what do I want? I want to say par.shapes of I is going to be equal to lines of I. Then we go down here. For int I equals 0. I less than. Circles. Dot size. And then we're going to do plus I. Man, I am typoing hard. Okay, then we're going to say par.shapes of lines.size plus I equals circles of I. There we go. Okay, so now we'll go over here, vi include, and we want to do aux functions down to create tree. It's a very nasty call, but that's okay. So we're going to do std vector of shape, and this is going to be lines, and std vector of shape, and this is going to be circles. Okay, add this in appropriately. So we're going to go vi aux functions. Oh, that's a binary. My bad. Vi source aux functions, and then we're going to pop down here and change create tree. Here it is, and we're going to do lines, circles, and down here we want to do pushback. We use lines that push back. Line. Nope. You. And up here it should be circles that push back. And then up here we do SD vector, like we had before. So it should be STD vector of shapes. And it should be lines and STD vector of shape, and it should be lines. Come on. Make that. Circles is not declared in the scope. Okay. What did I define? Circles, lines. I called it colors? What was I thinking of? There we go. Make that. Circles not declared in the scope. 885. Did I forget to write that? I mean, circles not declared in the scope. It's declared right here. STD vector out. Got it. Okay, what else do we have? Circles that push back was not declared in the scope. Great. VI source, aux functions, circles. Call it lines twice. Matt Smith? Oh yeah, I like Matt Smith. He's actually, of all the doctors, he's my favorite. Like him a lot. So now let's do Traverse. Nothing appeared. It's great. Great, okay. So let's figure out why nothing appeared. We reserved all the space. Oh, I know the problem. It should be part of shapes push back. Lines of I. Hey, Speckled Lemon, what's up? And then we're gonna do the same thing here. Part of shapes that push back circles. And circles of I. Go over here, make that, and that should be okay. And dang, nothing appeared. Why did nothing appear? Oh, I know why. VI source, and let's go into aux functions. That's not how I spell VI. Okay, let's go into shape, create tree. There we go. Nope. There it is. I need ampersands here. There, and there. And we go into include aux functions, and let's go into create tree, and should be down here. And 1 second. There. Hopefully this will be done. Make that. See what happens. Cyveal, traverse. Okay, there we go. Done. I'm not going to touch this anymore. We're finished, except for the fact that we have to do animations now. Okay, I'm going to commit what we currently have. Dirtface Dave, thanks for that suggestion. You're right. It worked. Okay, as far as the Doctor thing is concerned, actually, I'm going to be honest. The 11th Doctor is, like, by far my favorite Doctor, like, just hands down. But interesting story. Matt Smith, who, played the Doctor, when he went in for the interview, he wore his bow tie and everything for the interview. And he really thought he wasn't going to get it, so he just put on the craziest character he could possibly put on. And then after he put on that character and he was selected as the Doctor, he then realized, oh my gosh, I have to play this character for the entire, season or whatever, or the entire time as being a Doctor. So he actually didn't intend to, I guess the way he put it, he didn't really intend to be the Doctor after the interview. He thought he didn't make it. So I just find it interesting that he kind of thought his selection was a fluke, but I don't know, he's still my favorite by a good margin. I like him a lot. Okay, so now we have to remove all the C outs, so VI source, distributions, and let's go down to G, C out, remove these guys, and these guys too, because we don't need any of them. Actually, all that we don't need. There. And let's go to cout. There, and yes, we can remove that. vi source aux functions. Pop down here, and we want to remove any couts here. There. Root ID. Actually, that's okay. It's for the depth first search, so I think we're probably going to need that later. There should be another one here. Yep. Good. Write this, go over here, make that. One of these days, I will be able to type. You know, one of these days. A lot of warnings, but most of these warnings are comparison between signed and unsigned integers. Let's go ahead and attack these since we have them here. So vi source aux functions. I was already there. I don't know why I left. Source aux functions. And let's go to 141. For it should be size t. Just so we have a clean make, and then we don't have to worry about these anymore. Part positions. The next is going to be 256. So let's change this to size t. The next is going to be at 271. Yep, size t. Next will be at 288. And let's change that again to a size t. I'm going to comment these guys before committing, so I apologize for the delay. And then we need to go to distributions, vi source, distributions, and let's go to 774. I'm sure there are ones before this, but that's okay. Size t. Next will be 886. I know this is kind of boring, guys. I apologize for that. Size t here, and size t there, and size t there. Okay, what else do we have? Actually, that might be about it. Unused parameter par. Yeah, okay. Write this, go over here, make it one more time, see if it's clean. Of course it's not clean, because what am I doing with my life? Comparison between unsigned and unsigned integer. Yeah, it's okay, I got most of them. Okay, so let's go ahead and comment this guy in, and we'll go from there. So we have create tree. Creating a simple tree. Node root number, row number, tile number, node number, part shapes reserve. And drawing the tree. Oh, we should probably do line set reserve. And we're going to reserve the number of lines, which is going to be node num -1. And then we're going to do shapes, or you know what I mean, circle set reserve. And here we're going to do node num. The other thing I need to point out is down here, we'll say we need the circles to come after the lines for appropriate visualization. Yep, and that should do that. Creating a simple, I don't need these guys anymore. Array equals part of positions. I don't know what this is supposed to be doing, so I think it's okay to get rid of that. Go over here and make that. And then the last thing I need to do is comment the aux function that we created, because create tree is a mess. Vi source aux functions, pop down here, and let's get it done. Create tree. Okay, so what we're doing is we're creating the position. Green circle for this node. Yep, that's great. Correct. Aux variables for drawing. Defining node parameters, and then over here returning if leaf node, and creating array for drawing line. Okay, I think this is okay for now. So I'm gonna go ahead and commit that, and then we can talk about what we need to do next. So get status. Man, that was a lot of work for very little actually done here. Let's do get add source star get add include star get status and get commit -m, adding ability to draw simple tree get push origin beta. Okay, there we go. One thing up. Now let's talk about what happens next. I want to try, before leaving, a couple of extra things here, because So we spent the whole day drawing trees, so let's just keep going with that. I want to try drawing different trees. So create tree right now. We have a particular row number and a particular child number set. We change the child number to 2 to make it a binary tree. Let's go here and let's see if that works. Because I bet it won't. There's less IVL. Traverse. Oh, binary trees seems to work okay. Great. Let's do quaternary tree. Make that. I don't know what this is actually called. Traverse. Okay, this one seems to work too. Let's change this back to 3, and let's change this back to, or let's change this to 3 now. This is one that I don't think is going to work. Okay, so the X positions seem fine, but now the Y positions here are probably going to be crap. Yes. Yeah, this is crap. Okay. So what's happening here? Also, the X positions are now crap too. Everything's just crap. Let's just do a binary tree. R2. And let's make that. Did I hard code a 3 at some point? Oh, where are these guys? They're just gone. Great. Okay, oh, no, they aren't gone. They're here. These need to be dropped down a small position. And also, these guys are sharing the same location, which shouldn't happen. Okay. There needs to be a small offset to account for that. Oh, I know. So there should be a small offset to account for that, which should be equal to the radius. So let's go ahead and add that in. And then we have to figure out what's wrong with those Y positions. Yeah, so the problem is 1, 2, these guys are in the right position, that guy's in the right position, this row is not in the right position. Let me increase this to 5. Let's make that. Yeah, that's exactly what we're trying to do here. Traverse? Yep. Okay, the Y positions are definitely incorrect of those circles. Great, okay. So we don't yet have a general tree drawing scheme. Question is why, so let's go into VI source. And let's go into aux functions. The Y positions are incorrect, that's the problem. The X positions I think are okay, we just have to modify the X positions so that they don't overlap, which should be fine, it's just a matter of putting an offset in. So let's find the Y positions here. So we're drawing the circles here. We can create the position there. It should be 2 minus 2 times radius divided by max row. The max row in this case, unless we're reading it in wrong, distributions, pop down here. What font am I using? For the terminal, I'm using just something called Simple, I think. Let me go to select font. Yeah, okay, it's called Clean. Clean Regular is what I'm using. The reason I use it is because it doesn't look great at higher resolution. So the bigger your resolution is, it's pretty bad. But when you have low resolution, it allows you to see it better. So because I usually have very small terminals, it allows me to see the words very easily. And also it allows you guys, if you have smaller screens than I do, to be able to see it a little bit clearer. So that's kind of the idea here. It's not good at high resolution, so it kind of looks crap on my screen, but it should look pretty good on your screens if you're watching it on Twitch. That was the hope. Because usually I use much smaller terminals than this. So, okay. So, last thing we need to figure out, why is this Y position? So, it's going to be divide by max row. Let's go here. Let's see what we're reading in. Row number here. Max row. What's this 0 for? Create tree. Child num. Row num. Node num. Child num. Row num. Yeah, so reading in row num. Node num row. Row num. There we go. Said something correctly. Int num row is 3. Row num. Child num. Wait, where are we reading in the max row? Max row is going to be row num. Oh, okay, we're reading it again. What's this third one? Oh, offset x. Yeah, that's correct. It's supposed to be 0. Okay. So, in this case then, the row num... Yeah, okay. Okay, that's okay. So what we're doing here is we're taking the total size, which is in this case 2. We're dividing by max row, which is in this case 5. We're then going to multiply that by our I value in this case, which our I value is going to be max row minus num row, where num row starts at 5 and it counts down, minus 1 plus radius 0. It still seems to me like that should be correct. And in fact, I mean, it does work, right? So it works for small cases. So if we change this to, again, 3, this should work just fine. Savvy last traverse. No, 3 doesn't work either. Maybe just print out the param values you're passing in create tree, the ones that make sense. Maybe just print out the param values you're passing in create tree, the ones that make sense. Yeah, so the problem is because we're calling this recursively in order to generate the tree, it's kind of a pain to read all this out and understand which node you're working with at any given point in time. But what we can do is we can output these positions. So let's go ahead and do that. std cout. Along with a few other things. So let's do position of 0, 0. And new tab. Position of 0. Oh, never mind. It should just be position of 1 and 0. Sorry about that. New line. Put one here, and let's change this just to a 0. So these should be the positions. Let's go here and let's make that. Okay, and now we can output other things. So after we check this, traverse. Okay. Let's check to make sure these Y positions are correct. 0.9, 0.3. Basically 0. 0.9, 0, 0.9, 0.3. Okay. A lot of these are negative, which is okay. What are we looking for? We're looking for 4 that are equally distributed. So it should be basically 0, 0.3, 0.3, negative 0.3. No, it should be 0.6, 0.3, and wait. I'm sorry. Here's what we should have. It should be divided by 2. So we should have roughly these positions. We should have negative 1 up here. Then we should have 0.3, negative 0.3, and then negative 1. These are the positions we're looking for. Something like this, close to these. So let's see, we go over here, and we see we have everything except for the negative 0.3. That's the one we're missing, which is good, because that's what we saw in the visualization. Hey, Ward3Nart, thanks for coming in. Hey, Slayer Darth, I finally got my HTML validator in Vim plugin, sort of. Great, so I think it was Buttercake who was very interested in that. So I think he'd be pretty happy to hear that. Okay, so we have to figure out why these guys are basically 0. And the answer to that would be because the expression for y obviously turns into 0. I'm using CEXPR and getting all sorts of undefined variable error messages highlighted in red. Well, that's good. Highlighted in red. Good. Okay, so basically we're getting 0 when we solve this. 2 minus 2 times radius times max row minus 1 plus radius. Okay, so basically that expression is becoming is turning into 0 with some sort of weird error, which to me is kind of odd that it has like it's negative 2.77 times e to the negative 17th, but whatever, we'll figure that one out in just a second. So we do, okay, it's negative, that makes sense. I'm not seeing it immediately. Max row minus num row. Now for your first project, good luck, man. 2 minus 2 times radius divided by max row times max row minus num row. Yeah, I'm not seeing it. So it could be that max row minus num row is equal to 0, but that's not true. Do you use R at all? I've used R before, but it's been a long time. Oh, your next project, yeah, obviously next. It could also be 2 minus 2 times radius is 0, Nope, because radius, that's not going to be it. Divided by max row could be infinity. Nope, that's probably not it. Because max row is always being read in. Let's go ahead and output some stuff. So let's just do yeah, let's add in a new tab here. Where is it? There. And let's go ahead and add in more stuff down here. So we're going to output max row and new tab and num row. Okay. If it's hard to read, split it into a bunch of terms that are easy to read. Yeah, I think we're okay. So if we do make here, we go from there. University College London is offering a free course on statistical computing using R. Fair enough. Okay. So let's see what we got here. So these are the guys we care about, and it looks like it's 2, 1. Okay. So for 2 is for max row. Actually, every one of these guys should be 2 for max row. But it doesn't look like they are. Oh, this is super interesting. Max row should be the same for all of these guys. But it doesn't seem to be. It seems to be changing. So this means I'm calling it wrong down here. Num row, that's because I am calling it wrong down here. This should be max row. Make that. Traverse. Yep, there we go. Perfect. So let's go ahead and add in the X offset, and then we can go from there. So let's go ahead and get rid of these guys. And for the box size, it should be 2, but it's not quite 2. It's page up. It should be 2 minus 2 times radius. Let's go here. Let's make that. And let's go traverse. Yep, there we go. That looks pretty good. Now, there's going to be a case where this turns negative. So what we should maybe do just to get rid of that case potentially is we want to do absolute value of this. And let's make that. Side traverse. Okay, looks pretty good. Now we want to go into, what do I want to go into? VI source. Distributions. Let's go back to the case that we had before. So G down here. And we want to do, where are we? I want to do, no, that's relay. That's a while ago. Traverse here. So I want to change the child number to 3. And I want to see what happens if we just blow the tree up. So let's make that. And let's do source distribution. Oh, the last IVL. Okay. Yeah, so fine. Okay, it's fair enough. It kind of looks crap because the balls are so big, but if we drop the radius, it should be okay. So if we go into distributions here, G radius here, next. Yeah, we change this to 0.5 or something. 0.05. Make that. It should be pretty good. So we use IVL traverse. Yeah, it's okay. I mean, again, it's not great, but it's okay. And we also need to change the line width. But I'm not exactly sure how to do that one right now, so I'm gonna have to think about that one. Okay, so let's run quit. Let's do get status. And let's add this one too. So let's do get add source star get commit -m fixing small bugs in tree generation. Okay, that took all day, and I apologize for that, but we're done. So git push origin beta. Okay, so Euler 9090. What we're looking at here is basically, I was trying to find the appropriate way to visualize a tree. Now here's the thing, we've done this before for binary trees when we did Huffman encoding, but it's been a while. So we wanted to kind of generalize this and make it better. Yeah, this is not optimized C++ code at all. So basically what we're looking at here is a some code that allows us to generate trees that look okay. I mean, again, they're not the best trees ever, but they look okay. And these are meant to be for depth first searching and breadth first searching, which we'll be doing next time. So next time what we have to do is basically make it so we can color each of these nodes with time and show like the order in which we go through for depth first searching and breadth first searching. And then that's kind of the idea. So here we have the tree visualized. Now we have to do the animation, which could be difficult or could be straightforward. I'm not really sure. We're gonna have to do that or figure that one out. So we'll go from there. But anyway, guys, I think for now we are good to go. So again, this is a tree data structure, right? It's not like a tree you see outside. Just throwing that out there, just so no one's confused. I feel like I didn't have to say that. But anyway, we're going from there. So now we have basically the tree drawn. We have to go through. We have to get the animation done, and then we should be good to go. We're kind of a little bit strict on time right here because it's Thursday my time, and we need to get this done basically tomorrow. So tomorrow and the next day. So we have 2 days to get this done. And then I need to do all the writing for the Arcane algorithm archive so I can get the video out on Sunday. So that's where we're at there. I apologize for taking the whole day just drawing a tree. I know it takes some time, but I didn't expect for it to take that much time, but we're getting there. So anyway guys, that's it for today. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time, and I will see you around next time for the next episode of Simuleos when we get the visualization, working animation in. Should be pretty fun, pretty excited about it. So I will see you guys next time. Have a great day, guys. Bye, guys. Not really a class, but thanks for